Right, and we should be going live. I just finished the thumbnail. I want to do one little thing before we begin. I want to go ahead and get this. I'm going to mods. I'm going to just grab the world cleaner, select mod. I just want to be able to clean up loose world, specific blocks, world cleaner. Loose. Huh. Oh, I guess I was testing cannons at one point last time. That makes sense. The whole world. There we go. Yoink, this can go away. I have a plan for today. I have an idea in mind. We're going to try and build this. So first things first. There's 8. 16. 32. But my goal is to, instead of having one long 256 block drive, effectively, this is going to have 4 64-bit drives stacked together in such a way where I can run all 4 of them off a single um, carriage with 4 separate read heads attached. Hope is that will allow me to use a lot less pistons and kind of share the load between a physical read head and a digital one. And if I can do that, and if this works, then I'm going to see if I can get this functioning. The only downside I see to this design is programmability. Because right now I'm going to have to like get in here with the paint tool. This doesn't seem half bad. This, I guess if this is on a lift, I could get it at just the, yeah. This wouldn't be that awful to try and program. I'm going to give this a go. I still want this to be relatively compact as well. So that's another factor. Here's what I need to calculate. So I'm gonna need 1, 2, 4, 6, 8, 16, 32. I'm gonna need 10 pistons for this to run. So if I do this the way I'm intending it to, there's going to be piston 1, spacer 2, 3, 4, 5, 6, 7, 8, 9. And that's assuming I don't stack them. So I'm just going to do this. Piston carriage here. 1, 2, 3, 4, 5. Then loop these back. active piston. 1, 2, 3, 4. I want to bring this back one more. No? I'm gonna keep going with this. See where this lands. I might modify it in a minute. Four, 5, 6, 7, 8, 9. I'll just go back one more. This is where the carriage is going to go in. Not the most slippery block possible. Here's where the fun part comes in. Put this. Color mode blank. Bodies on the same creation and no friction. I'm not entirely sure about that, but fair. I'm just gonna do it because it makes me feel better. Color mode blank. I'm gonna go ahead and do the other side of these. So 4, 5, 6, 7, 8, 9. Okay, enough. 4, 5, 6, 7, 8, 9. This needs to be 10. So these, I'm gonna go and paint this gray. Paint these. I think these yellow. Let's put this back on the list. And I'll get to those in a second. Here's what I want to do next. Interactive. So first, this will move 1. This will move 2. This will move 4. This will move 8. This will move 16. I might not have needed the 10th. If I don't need the 10th, I'll just cut it in a minute. This will go to 32. 32. 2. For the time being, these all OR gates And switches. And the end of this. Now, guess what I want to see. Set these to fast. This last piston is not actually required. So I'm going to remove it for rigidity's sake. Oh, the OCD is going to kill me. I'll just reverse these. OCD is still going to kill me, but at least it's symmetrical. Now I get to hook them all up. Oh, I made a mistake. One, 2, 4, 8, 16. $16, 82. One, 2, 2, 4, 8, 8, 16. 32. Oh, not even welded. Let's do our logic. Set these to color mode. So far I haven't crashed the game yet, so at least the frame rate's better. Hello, Bard. That's Barab. I'm just gonna call you Bard. Hello, Bard. Hello, Gopnik. That's not. There's no P in that. I don't know why I wrote it that way. Ganache. This design is mixing the digital system with the analog. Essentially, I'm running four 64-byte USBs in tandem and just switching between the active read heads. So I can use one carriage to move all four read heads, which allows me to reduce the amount of pistons, but also increase the but also increase the pistons for more rigidity, therefore more stability, therefore more speed. Yes, I'm the guy who is doing a lot of scrap mechanic tanks. That is what I was very well known for a while. Once I finish these connections, I'll step back and actually take a look at the drive as it is currently. This is what I'm working on now. Will effectively be the switcher between the four heads. After this, I'm going to put in the binary counter. So right now, what this will eventually be hooked up to a binary signal. But this is the read head. On here is 4 sets of sensors. Each one of these is its own writable section, and I can kind of sneak in here at the paint tool to write these. A little claustrophobic, but it should be okay. And it's a very short drive, but it stores the same amount of data. It's just a little bit thicker. Effectively, this moves it 1. This moves it 2. So there's 3. This moves it 4, 8, 16, 32. In total, it starts at 1, ends at 64. Essentially, it is 4 individual read heads stacked on top of each other. Yes. I'm sorry, I'm halfway away from my mic, that's why. My good mic from when I was recording last died quite some time ago. So I'm using actually the original mic that I've been using for when I first started the channel. To answer, yes, it is technically reading simultaneously. However, I can select which head will output. So, real quick, I'm just going to bring this back towards the front. If I were to put one, so actually, let's do it like this. If I were to do 1, and then 2, and then 3, this one I'd have to put on the lift. 4. Now if I select track 1, outputs 1. Track 2, outputs 2. Track 3, outputs 3. Track 4, outputs 4. And this will be controlled by the binary counter when I get that set up. Yes, one USB ends, the other USB starts. So think of this as like track 1, track 2, track 3, track 4. Each one of these is 64 blocks. 64 times 4, 256. This is the same size data storage as the 3D V.2 as this thing. This drive has the same amount of storage as this drive. Instead of it being long, it's a little bit taller. And it means because I've compacted it and I'm using one single read head, I can use less pistons. And because I can use less pistons, I can actually double up on the pistons to make the read head. Yes, 256 bytes is how much this singular drive will hold. When I finish the printer, I'm expecting it to accept 3 or 4 of these USBs. I'm expecting to get like a kilobyte of storage in this next 3D printer. I think it's a kilobyte, 1,000 bytes. Yeah. That is the goal. That is the plan, is to have the USB or the 3D printer Mark II running a kilobyte storage. Real quick, I'm going to go AFK because I need to go take care of laundry. And as soon as that's done, I will be back doing some more of this. And as soon as I get back, the next project will be a 8-bit counter that will run the read head automatically. I already have a plan for the actual like coding language. It's going to be different than the old printer. So there's like 3 or 4 improvements. One is I want to make the USB much sturdier and faster, which is what this project has been. Colored. What do you mean? I can color black or white for this data stuff. Oh, the colored these, because this is the actual output that reads. So I'm marking like important sections of things with like paint tool so I can see where they're at. This one could theoretically get colored, but I'm never going to need it for debugging. I shouldn't need it for debugging. One, because I want this to be relatively easy. I'd rather be working in 8-bit than working in like hexadecimal, which is what you start getting into when you get colors. And ultimately, I want this to be a project that another person could pick up and work with. And I think color programming starts to get in that realm of like, there's no way another person could pick this up and figure it out without like a full essays worth spreadsheet. Well, yes, you can have 8-bit, but so you'd have to have 8 sensors per line or per block. And at that point, I'd rather just do this. I'm not doing like glitch sensors or stack sensors and stuff. Okay. I'm gonna do like I said. I'm gonna go AFK for a moment to go check on laundry and possibly switch it out. When I get back, I will be doing the binary counter. And when I do the binary counter, this should be actually approaching finished. This is so much easier than any of the other logic designs I've been doing. I'll be AFK for 2 seconds. And I have returned. I almost want to do piston logic, but I'm not. So let's do WB. I'm pretty good. Go ahead and my paint tool there for a second. Most recent update to what I'm doing, or most recent update to Scrap Mechanic? We have gone to a mix of a physical and digital read head. Essentially, I am running four 64 byte drives simultaneously, and then just changing the active read head. So all the read heads are on one carriage that moves simultaneously, and then I can just select which output I want to read, and I'm trying to do a best of both worlds thing. Okay. Ew. This one needs... You're going to have to manually write the byte data. Why not just have a switch panel? Because a switch won't save on a lift. I'm mostly against glitch welding and blueprint editing. I'm like fully against blueprint editing. Glitch welding, I've experimented with in the past, and genuinely, I don't care too much. I do try and avoid it when possible. this up. I think I have this completely wrong. So with this, let's see. So if my thing against blueprint editing is you start to go to stuff outside the game, and once you start adding like external tools, not as big of a fan of it. Like people have built applications to do stuff. I don't particularly vibe with it. So if I hit back, what I need it to do is toggle the first one always. And then I think I need a row of knots. Because then if this will always toggle. And then if this is not on, then it will toggle this one. Correct. It has been so long since I've done binary work. I could get away with just having it count up, in all honesty. There we go. Or and not this. This and not this, and then this and this. I will have a manual. So if I do this, this is drive 1, and then extension 1, 2, 3, 4, 5, 6, so on and so forth. This is drive 2. And then I go. If I do that, there we go. And drive 3. Drive 4. Hey, there we go. If I do this, it will... Oh, that was red. Okay. This will go through... Stack overflow back to the first drive, first position. Ooh. All right. Now I need to do set. I need a reset and a set. Reset, I'm just going to put under here. So if it's on, and the reset is sent, then it will toggle itself. Oh, I need to... idea why this got in your feed. A 12-digit comms terminal. That was hard. Good luck. Spud, this is not my first attempt. So if let's just click through this. Now if I hit reset, cool. Say if I do this the other way, hit reset, cool. Turn all these on, all these turn off. Reset works. Actually, I want to do this. So now we have a reset. Makes window painting and desktop window management look easy. Oh. And then I'm just gonna do a handful of AND gates. And then AND NOR. I should have just hooked an OR gate up to these so I could just hit all 3 XORs with a single OR gate. This is going to be the set in a minute. Actually, what I want to do with this is instead of it going straight to these, do and not. This is going to ping the reset pin. That does its function. Then, after a mild delay, it will copy whatever is written on these to USB for a quick test. Yeah, this is the head controls right now. So we have forward, backward, reset, and set position. So if I set it to fourth channel, third position, and then if I do first channel, whatever this is, done. We now have the ability to set, reset, forward, and reverse. So if I do this, reset. I'm gonna see how fast I can set this before it breaks. That's reset. Cool. May not have even needed this. How are you going to control the pace at which you read the USB? Basically, my plan is to have an internal clock. I'm gonna have a signal that says read, and then the USB is going to one of two things: either the computer is just going to handle it, um, and just have it part of the clock, part of the read command that I'm going to put into the 3D printer. That's probably what I'm going to do. And I'm just going to have it like a set time, a fixed time, um, which should be equal to whatever the farthest movement from 0 to 64. So however long this takes, go from this to this is the read speed. And I'm just going to define a number for that and tweak it until it stops breaking. All right. Clean this up down here. And then I'm going to go ahead and actually hook up the pins interface. So I'm going to delete some of these temporary testing. And what this is going to ask for is 8 pins. Then pistons. So there's the set. There's the command for set, reset, forward, back, which are all receiving. And then these pistons, I'm going to go ahead and hook up some manual controls for this as well. We're going to push pins. Am I going to change the actual painted blocks only? Yeah, I'm going to have a pin interface. Because the whole idea is these cartridges should be relatively easy to switch out. That way, if, say, I build this printer and I upload it, someone can make their own coded cartridge, upload that cartridge to the workshop, and all you have to do is weld it to the printer and hit start. Like, weld, like, fucking yellow pin to yellow pin thing. Which is what I did with my original. Oh god, that's an early build. 3D printer project, yeah. So there's the pin interface right there, and it's just a single block. You disconnect that, the USB falls off, and you can plug a new USB in, and it can print something entirely different. The reason I'm not doing the white blocks by themselves is I want this to be a self-contained item. So if I want to reuse this in future projects, all of the major logic is here to run the drive independently of a full computer. Like, I could write music on this USB and hook it up to a simple, like, piano setup and have it just play. And I'm going to have reset. That green. Yeah. I'm going to have hard reset. So reset goes to there. Set goes to there. Yeah, but then all I have to do is use the pin interface. I don't have to have all of this logic as separate, like, systems. Green goes here. Red goes here. These pins go by this, and I'll set those up in a second. Also, I think the idea of plugging and unplugging a pinned logic looks really cool. And part of it might just be the aesthetic I like. So 1, and I'm going to do speed not full. I forget where it is that the 1 block pins break. So if I'm going to do something as well. I am going to color code these white. So that these don't get messed with by something just brushing past them. What I'm going to do I'm going to do set reset. So that way I can have controls here if I really want to. This shouldn't interfere with the way these attach. So if I full reset, then I can count forward manually. Actually, I want these on the side. I don't want them... Because once this is interfaced, I won't be able to see these. I want these mounted over here. Because for some applications, I do actually want to manually control this. Or if I'm bug fixing, this will come in handy really easily. So reset. Audio shuttle. So now if I hit reset, cool. And this, oh, that's what I was checking. I was checking to see how fast I can make these pins run before they break. Oh, I see what's happening. This is jittering a bit more than I would like. Oh, and it's not fully oh, I'm dumb. This is in the way. There we go. Reset. Set. Forward. Push. Now if I do that. Okay, that is a little too fast. That is when it starts to jitter a little bit. I may see an issue. If I do this, I don't know why for like a split second it's reading multiple tracks. But here it's doing just fine. If I reset this, and then I'm gonna do this. I can't do that. Okay. I'm gonna retrofit this. Six, 7, 8. No, I think what it is just the way this logic is set up. I'm not too worried about it because in normal operation it should be fine. It's just that when it's jumping that far and all these turn on automatically, that's where the issue's coming from, I believe. So now if I want to do, let's reset. That was not the right, that's reset. So now if I want to do this, I can switch channels. Yeah, it pings for just a moment, but that's okay. I'm not going to be using it as a set point anyway. Facing the sensors. Third piston from the left isn't connected. Oh, there you go. There we go. Yeah, you can see for just a second some of those ping. And I'm not even sure if that's enough for the piston to register it. guess I could. Now I reset and then I set. It jumps back and forth cleanly. Nice. At this point, the drive's done. There's nothing else for me to really do. At this point, I'm thinking I'm ready to put a shell on this. I think that I'm going to leave, for the most part, open. But I do want to cover some of this up. Oh, the reader is easy. I'll do that later. I'm going to add a glass window here. Those and these. this, I'm going to set this up so that it does not use connection points, so that I can easily, quote unquote, easily access the editing section of the drive, the editable section of the drive. What I want to do is then take this. Yes, I'm planning on doing 32 squared. Once I finish this drive, and once I go through like one more test with it, that will be the end of the string. Once the drive's done, that's my goal for the day. After this, I'm probably gonna start on the actual printer, like print head, getting that mechanism functioning. The idea now is if I take that, this pops off. Okay, that is one thing I actually do want to change. This is going to end up here. Now, so this way I can come in here and edit it, make any changes I want to it. I can even come back in here a little bit. And when I'm done doing whatever I want to do, I can simply place this. Take this. That. Yes, I am going to have the printer understanding instructions. It's not going to know every individual block. It's going to be like draw line functions. And last but certainly not least, Actually, I've got a better idea. Just because I think it'll be fun. No, I don't like the screws. It's another, like, shiny metallic that would work well. I could just go metal. This got painted at some point. Putting these on here just so it can't connect improperly. Such a stubby. So my plan is to, let's say I want to move the head. I'm going to have a select material, because I'm going to have a main material, I'm going to have a support material, and then I'm going to have no material. So if I want to move the head, I would select no material, and then the draw line function, which would draw a line putting no material down. And that would allow me to move the head freely, and then I could just select material solid and then draw it, or select material support and then draw it. The case is connected to the far end. Down here? Oh, yeah, you're right. Right there. Before I do anything else. The little derpy. Hey, if this stores the amount of data I need it to, 3D V.2 hybrid USB 256. Wait. So now if I want to edit this, I do this. I put that there. I want to put this back. This just goes there. $32 benchy together, yeah. And then make sure this runs. Ooh. That jammed. So 3D V.2 hybrid USB 256 bytes. Big title. I know. I'm sorry. Immediate jam. Also, yeah, this has I know wedges have always had nasty hitboxes, but I thought they would have fixed it by now. Because ultimately, what I want to see when we are doing this printer slap this on here real quick. I want to be sitting here, like time lapsing the printer and seeing it do something like this. Okay, 20 seconds is not enough. 25? 25. What's that? 25 ticks. Which has an on and off period. So basically 1.4 seconds is how long it takes to move this read head. Okay, real quick. And to give you a sense of scale, and to test the frame rate. This is what I'm expecting to plug into the printer. God, putting this into perspective now. I'm in danger. Just get a screenshot of that. 256 times 4. So, what, a kilobyte? Yeah. 1024 bytes is 1 kilobyte. No, this is the storage. This is the ROM. This is going to hold the code that the printer reads. The sense of scale that this gives me. Oh, God. I'm terrified. Oh, Spud, if you look at the time lapse for my last 3D printer, that physically took, I think, it was like 2.5 hours to print. I literally just set up my computer, recorded, and walked away. My goal is to get this print like much faster than that. Um, which was why I was doing so much work to improve the actual data storage system. But also, yes, I'm increasing the size. So in theory, it kind of counteracts itself. However, I'm hoping to not need the full kilobyte. I have some plans in mind. One, how I'm going to cover things like supports, infill, layers that are similar or replicate. What's going to be difficult? Got a message like 30 minutes ago. My partner's yelling at me about laundry, by the way. Um, yeah, this seems to be like the rough speed of reading a command. Thing is, also the print head has to execute on that command. So I don't think the limiting factor is going to be the data read. It's going to be the print head moving. Um, with that being said, the data storage device is finished. Unless there's a bug or something I need to address, it's working. Yeah, the bottleneck's going to be the print head. So unfortunately, I am going to have to end this stream here. Next week, I'm planning on starting on the print head and the whole printer selection. From there, then the whole thing is going to be interfacing this data to the printhead and actually writing all of the code and creating all the different chips and chipsets that this is going to run on. So, data storage is done. Next week, we start on the printer head. I'm going to end it here. Thanks for stopping by. Thanks for sticking around. And until next time, peace.